Welcome back. I'd like to give you some hints on how to do this next homework, which is an implementation. Basically, what I'm asking you to do is take a code base that I'm giving you and get it working, and then take that code base and use it to write some additional code. Right, so I've given you linked list PDF and circular list PDF. These contain complete source code for a list container using two different implementations. Then I want you to take this other document, which I'm going to go over here, and use that to help you modify the code that I've given you to implement these other containers. So first of all, start with linked list and circular list and get those list containers working. And then once you've got that working, write a bunch of new programs. And yeah, you could just write whole separate programs, or you could combine these in some way. It's up to you. I think it's easier if you write 7 complete sets of source code, even though most of it's going to be the same. There's a whole lot of cut and paste going on here. A lot of cut and paste with a little bit of editing. So it's not super hard what I'm asking you to do once you understand what I'm asking you to do. But I think the easiest way is just cut and paste code from these guys into new programs and get those programs working. So the 7 new programs I'm asking you to do are 7 new containers. So they are a stack, a queue, a priority queue, and using a circular implementation. So you'll modify the circular list PDF to produce these 3 guys. Then I'd like you to do another stack, a queue, and a priority queue using the linked list implementation. So I want you to modify the code in linked list. Then I want you to throw in a doubly linked list. So there's going to be a bunch of functions that define the interfaces to these guys, and I want you to list the big O for each one of these functions. And then yeah, so in detail, what are the interfaces for these? Okay, so I want you to do a stack, a queue, and a priority queue using circular lists, a stack, a queue, and a priority queue using linked nodes. And what do I mean by a stack? Well, it's going to have this interface. That is, it's going to have these set of functions. There's a push function, a pop function, a peek function, and it is empty. And push just appends data to the head of the list using, well, depending on whether it's a circular array or a linked node, it'll put it at the head of either one of those. Pop removes from the head, okay, and then peek just returns a copy of what's at the head. Right? That's what a stack does. Then a queue. Well, let me back up for a second. So a stack, logically we think of a stack like this, things sort of stacked up, and we're putting in at the head, and we're removing from the head as well. That's a stack. So it's items come in at the head and they come off from the head. Yeah, like a stack of dishes or something. Now a queue, I want you to so you're going to append to this is going to be the tail that you're going to append to, and then the head you're going to dequeue. So you have a queue operation. So a queue operation that appends to the tail, and then a dequeue operation that removes from the head. So I probably could have wrote this a little bit different. For the stack, you're going to pop and push, but both of those operations are going to happen at the head. Let's draw it that way. For a queue, you're going to append, which we call queue for this thing, at the tail, and then remove or dequeue from the head. So implement a queue operation and a dequeue operation and an isEmpty operation, which is the isEmpty is pretty trivial. Okay, then a priority queue. Priority queue is it's still going to insert at the tail. So there's going to be a no. It's going to dequeue at the head. So the head is up here. tail's over here. You're going to dequeue at the head. So this is a priority queue. You're going to dequeue at the head, but you're going to insert. Insert's going to insert in sorted order. So it's going to scan starting the tail and scan all the way down until it finds the proper location and then put it in there. It's very much like the insert sort operation. If you go back and look at insert sort, it has a little piece of code in there that scans for the correct place and then sticks it in there. All right. So that's dequeue and insert. And then peek just looks at what's at the head and returns a copy. Okay, that's priority queue. And doubly linked list is just there's only going to be one implementation of these, and that's the linked implementation. And basically, you want to be able to go forward like this and backwards like this. You want to be able to go both directions in this thing, so you're going to have 2 pointers in there. Instead of just a next pointer, you're going to have a previous and a next pointer. Okay, so there's previous, next, and data in the middle. Right? And this is fairly simple. Just take the, it's going to be as similar to the list, more similar to the list than anything else. Okay, so this seems like a lot, but it's not really. And to help you out, I have given you this summary sheet posted in, this is containers .pdf. So a lot of this stuff is the same. For example, the push operation for the circular array and this linked list is the same. No, that's new. But pop is the same as remove. So we remove from the tail, and that's what pop does. So to implement pop, all you got to do is take this remove operation, change the name. Just, okay, copy and paste and rename it pop, and you're done. The same with isEmpty, it's the same. For the queue, it's exactly the same as remove and append. They just have a different name. Remove removes from the tail, and append appends to the head. It's the same. Most of these are the same. The only new ones that you have to write are push, peek, and insert. Oh, and then there's these, but these are actually, you'll find that these are easier than they seem once you look at the list implementation. You just need to add another pointer, and then the code that goes like traversing, you just need to rename that traverse forward, and then have a loop go backwards using the previous pointer instead of the next pointer, and name that traverse backward. These are fairly easy. Once you get these done, okay, you'll be able to do these. Okay, so to help you with these, I've got some diagrams that I'd like to go through with you. So push is new, peek is new, and insert is new. Let's study those in a little detail, and then I think you'll be able to figure out these. Okay, so what is peek? That's a new function you gotta write. And I didn't want to give you the code, so I gave you the prototype. That is an empty function, and then I give you this little picture here. So this one's pretty simple. It's just returning a copy without modifying the data. So if you've got 2 cases, the list could be empty, which looks like this in diagram form, in which case you return -1, or you just want to take a copy of the data that's at the head and return that. So to help you understand what these pictures mean, look at the also posted documents that I went over in detail in the video before. where, for example, I have these little diagrams. Like, I want you to write this for a circular array implementation. This is the linked list implementation, but you know, so do that one first, I guess. But you know, here's an append operation. So the reason I gave you this here is that for many of you, it may be the first time you've seen these kinds of pointer operations. So I wanted to give you a diagram, and I wanted to give you code that's complete. This code is totally functional. All I did was I changed the font and I made it into a bitmap so that you have to type it in. Okay, so I just want you to type this stuff in and get it working. And these diagrams are intended to help you kind of understand this code a little bit better. But then I'm asking you to write a brand new function. I'm just giving you the diagrams and I'm asking you to write the code. Okay, so that's peek. Append looks like this. So here we want to append the item to the head of a list. In the implementation I've given you already in this thing here that we've gone through that's posted, this is list implementation PDF. I have an append operation in here, but this one appends to the tail of the list. You need to append to the head of the list. Okay, so study this tail append thing, and then, you know, think about it, and, you know, have a nice cup of coffee or whatever, and like try and spend some time visualizing this. But here, I'll kind of go through go through it with you a little bit. So we need to make a new node no matter what. You've got code in this thing here that shows you how to make a new node right here, and then you've got code to check if this is empty. If it's empty, then this is what it looks like. The head and the tail point to nothing, and then you've made a new node using a pointer P, presumably. So here's your new node that you've made, and then here's the condition of the list being empty, and then afterwards it's got to look like this. So there's code that in that other document that implements this picture. All right, then if the list is not empty, that's this case. So in that case, we've got a head pointer, and we've got a new node that we're trying to hook up to the head because we're appending to the head, and which means that we need to move the head pointer back. Okay, so make this head pointer be P. That's basically the line of code you need to write, and then make this P next be head. And that's basically the line of code you need to write. You need to do that in the proper order. I might have said that backwards. I'm not going to tell you. But there's just a couple of lines to get this to work. All right? Now the last function I'd like you to do is the hardest one. So I've kind of given you all of these pictures right here. And let's kind of go through them. So this is insert. So this is for the priority queue. This is for the priority queue, the thing that looks like this. Insert goes along until it finds a certain location, and then it sticks the data in that location. And dequeue is on this side. Okay, so this is the insert function. So we need to make a new node. That's what that is, right? Yeah, make a new node no matter what. Then this thing could be empty. Then why are we returning there? It just says return. It seems like I cut off a little picture here. I mean, what you really need is you need to just hook it up at the head, which is the same as the tail if this guy's empty. So hopefully you're watching this video, because the document I posted, I don't think it has this little picture. Anyway, you'd probably be able to figure it out. Okay, otherwise we got to do this. If we have more than nothing, do this. So we've got to, I'm using a cursor and a precursor, and I'm walking down until I find the, I'm walking down while the data in this guy, while P data while P data is greater than C data, right? Because these will be sorted, because assuming you only put data in here with insert, then these guys will remain sorted the whole time, because inserts in sorted order. So these are sorted. So you just walk P down and while it's greater than C, and so this will stop at a location. And there's 3 cases where this guy will stop. Okay, there's 3 cases. So it's possible for the new node to be bigger than all the other nodes. That is, the data in the new node to be bigger than all the others. In which case, this previous loop will run off the end of the list, and it'll look like this. Then what I got to do is I got to take this new node and attach it to the end. So I have to take T and scoot it down, and then I have to take this pointer here and make it point to the new node. Okay, that's if case 1, if the data in the new node is bigger than the data in all these other nodes. And the other condition is if the data in the new node is less than all the other new nodes, in which case you need to scoot the head pointer back and put the new node at the beginning of the list. Okay, and the third case is the data in the new node is somewhere in the middle. So basically C will stop, the C cursor, rather, the little c cursor will stop somewhere in the middle of this. And it might look like this. You might have the head pointer, the tail pointer, the cursor, and the precursor. And I've labeled these nodes up here with capital letters, A, B, C, D. Basically, you need to put the new node between capital B and capital C, between the cursor and the precursor. Okay, so you need to adjust the pointer values here and here such that you have this situation here. Okay, so hopefully these diagrams will help you understand what the functions need to do, and look back on the other PDFs that are posted for this assignment, and there's code that's associated with diagrams that will help you translate these diagrams. And do this stuff first. So once again, just high level, what am I asking you to do? I'm asking you to take this document right here and the corresponding document for the linked list and get all this code working. Type this code in and get it to work. This is fully functional code. So get that to work. It should compile. If it doesn't compile, you typed it wrong, or you have issues with your particular compiler or something. But get this working. Then modify these functions as appropriate. Some of them you just have to change the name of the functions. And most of these are the same. You just change the name, but there's a few that are new. All right, and that's what these diagrams are for over here So have I covered this pretty good? Let's see. It's the second page of this thing. Yeah, that's pretty much it. All right. So get the old programs in linked list PDF and circular list PDF. Get those working. Then use that as a code base to write a bunch of more new programs. Okay, some of which use the circular list implementation and some of which use the linked list implementation. Tell me what the time complexity of all of these operations are, and these are the particular operations I want you to implement. All right. For these 4 functions for the stack, and they're going to have particular time complexities, and they're going to be based on the list functions: remove, append, find, traverse. Okay. And then for the queue, write these guys and tell me their time complexities, and these are going to be based on the remove, append, find, traverse functions. And priority queue, same thing. Write these for the circular array, write these for the list array. So it's not a whole lot of new code. It's just a lot of cutting and pasting and changing some names and then writing a couple of more new functions. All right? Send me this big, huge chunk of code. It's going to be a bunch of pages, electronic pages, and then screenshots of the code compiling, and then text of the testing functions in main. Put in lots of testing, more than this. Of course, you're going to be calling push, pop, queue, append, insert, blah, 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 for all the functions that you're writing. This should be a very large script that has lots of output that shows that these guys actually work. All right? Hope you have fun with that. Hope this was helpful. See you next time. Bye-bye.